Okay, hello everyone. In our last class, we discussed about basic rules due to the partial fraction for different types of QS, and we discussed the questions and corresponding answers of type 1 and type 2. In this class, we are going to discuss questions and answer belongs to type 3. That means non-repeated quadratic terms if in the denominator, then how we are going to consider the partial fraction. The first question belongs to type 3 is your s by s square minus 2s plus 2 into a square plus 2s plus 2. We have to find out the inverse Laplace transform of this one. First we are going to consider the partial fraction of this one. So here you can see that this one is your one quadratic term, this one is your another quadratic term. So what we have to do for the partial fraction, that means s by this much equal to as plus b by this term plus cs plus d by this term. Okay, as we have been discussed for type 3 rule. Type 3 rule means as plus b by this one. If another quadratic term will be there, then we have to write plus cs plus d by that term, that what we already discussed. Now we have to add these two terms. If I'll add it, then as plus b into this term plus cs plus d into this term, whole divided by this into this here. If I'm going to compare LHS and RHS, the denominators are same. That means the coefficient of numerators of both LHS and RHS has to same. That means A is equal to this one. This that means the numerator itself. The numerator will be numerator of RHS. That means coefficient of numerator will be coefficient of numerator of LHS, and coefficient of uh, uh, s square will be equal to with LHS. Already we have been discussed in our last class, right? So you just multiply that as into a square, as cube, as to s, 2a square, as 2s, b a square, b into 2s, 2bs, b into 2b. Now if I am going to multiply this two term is this one, we can found csq minus 2ac 2ca square plus 2cs plus ds square minus 2ds plus 2d. Carefully you have to watch, and carefully you have to also write in your note. That implies s will be equal to q, here one term, q another term, so sq equal to a plus c, square term here, here, here. So here 2a b here minus 2c, here d plus d square plus s terms are here 2a, 2b, 2c and 2d, 2a plus 2b plus 2c minus 2d, and constant terms are this is 2d is there and another 2b plus 2d. Now equating the coefficients of s cube, s square, s0, that means this one, this one, this one, this one. S0 means here, means 1, s0 means this one. For LHS and RHS we get. So if I am going to compare coefficient of SQ with RHS, LHS, in your LHS there is no SQ term is there. So S plus C will be equal to 0. That means A equal to minus C, right? A equal to minus C. Now compare this one. This term with the coefficient of A square belongs to LHS, but there is no S square term is there. So coefficient will be how much? 0. So 2A plus B minus 2C plus D will be equal to 0. So here we found A equal to minus C. We just put it will be minus 4C minus D minus D plus D. Here minus D means B equal to minus D. Here we can found, wait. Okay. So then we have to consider the coefficient of S. This one 2A plus 2B plus 2C minus 2D will be equal to 1. Here S is there. So coefficient of S is your 1. So we have to write this one 2A plus 2B plus 2C minus 2D equal to 1. Okay. Then constant term your 2B plus 2D. There is no constant term in your LHS, numerator of LHS. So it will be 0. So here from this we found b equal to minus d. So here if I will put b equal to minus d, then this will be minus 4c minus d plus d equal to 0, because a will be minus c, so minus 2c, you have 2c minus 4c, so d cancelled, so c will be equal to 0. If c will be 0, obviously a equal to 0. So hence if I will put c 0 and a 0, from this we can found b plus d equal to 0. Okay, now consider this one. Here a 0, c 0, so we found 2b minus 2d equal to 1. You just multiply 2 with this equation, 2b plus 2d equal to 0, and then add both the equations. So we found 2d got cancelled, minus plus, so here we found 4b equal to 1, b equal to 1 by 4. As b equal to minus d, so d equal to minus 1 by 4, d will be minus 1 by 4. So this is your d actually. Okay, this is your d. So we found b equal to 1 by 4 and d equal to minus 1 by 4. Now we are going to substitute these a, b, c, d values over here. Okay, so here this will be 0, a will be 0, and c will be 0. This term will be 0. b is nothing but how much? 1 by 4. d is minus 1 by 4. This is 1 by 4 into this much minus 1 by 4 into this much. So s by this one, by considering partial fraction, we found equal to 1 by 4 into 1 by a square minus 2s plus 2 plus this one is 0. So d means minus 1 by 4. So minus 1 by 4 by a square plus 2s plus 2. Now we have to take the inverse Laplace transform both the side, because we need to find out inverse Laplace transform of this one. Inverse Laplace transform of this one will be here 1 by 4 constant taken outside, inverse Laplace transform of 1 by a square minus 2s plus 2 minus 1 by 4 taken outside, inverse Laplace transform of this one, a square plus 2s plus 2. Okay, now this one 1 by 4 inverse Laplace transform of this one minus 1 by 4 inverse Laplace transform of this one, whatever written in the last page, same I have written over here. So this a square minus 2s plus 2 can be written as s minus 1 whole square plus 1. S minus whole square means a square minus 2s plus 1, here plus 1 plus 2 is there. So this can be written as s plus 1 whole square plus 1. Here you can see s plus 1 whole square will be a square plus 2s plus 1, and another one will be added up and it will be 2. So if we are going to consider 1 by a square plus 1, or this can be written as 1 square itself, 1 square, and this is 1 square, this is the value will be sine at, means a is 1 sine t, but as it is s minus 1 is there, so it will be e to the at as per your fast shifting theorem. Here we have to write by fast shifting theorem, it will be e to the power at means 1 t into sine at minus 1 by 4. Here it is nothing but s minus of minus 1, so it will be e to the minus t into sine t. Okay, so final answer will be 1 by 4 sine t taken outside e to the t minus e to the minus t is your answer. Now we are going to go for the question belongs to type 4. Type 3 denominator is not repeated quadratic, but type 4 we can found repeated quadratic. Here you can see we have to find out inverse Laplace transform of this one, a square minus 6x plus 7 by a square minus 4s plus 5 whole square. That means denominator quadratic is repeated 2 times. So how we are going to do the partial fraction here? Okay, so the partial fraction of this one will be written in this format, that as plus b by a square minus 4s plus 5 plus cs plus d by a square minus 4s plus 5 whole square, as we have been discussed that for type 4 it has to be written in this format. Suppose quadratic repeated factor is there up to r, that means that term square up to r we have to write. So here quadratic factor is repeated 2 times, so here we have to write as partial fraction as as plus b by a square minus 4s plus 5 plus cs plus d by a square minus 4s plus 5 whole square. Now if we are going to add these 2 terms, then it will be as plus b into a square minus 4s plus 5 plus cs plus d. So here we can see that The denominator of this RHS and LHS are same, so numerator has to same. That means a square minus 6s plus 7 will be this one. Okay, I just multiplied all the terms. Here you can see asq minus here asq as minus 4s, that means 4a square, as 5 b a square, b minus 4s minus 4bs, b into 5b. This is your cs plus d. So here asq and a square terms are this one minus 4a1 and here b. So b minus 4a. A's terms are 5a minus 4b plus c. Here I have been written plus 5b plus d is your s to the power 0 term. S to the power 0 means 1. S to the power 0 means 1. So here we can see that this one 5b plus d is your constant term or the coefficient of s to the power 0. So here a is the coefficient of s cube, b minus 4a is the coefficient of s square, 5a minus 4b plus c is the coefficient of s, and 5b plus d is the coefficient of s to the power 0. So now if this left hand side will be equal to this one, that means coefficient of this power s to the 3, s to the 2, s to the 1, s to the 0 has to same. So now we are going to equate the LHS and RHS coefficients of this SQ, S square, S to the power 1, S to the power 0 we get. Here you can see coefficient of SQ is your A. Left hand side there is no SQ term is there. So A will be equal to 0. So here S square coefficient B minus 4A. Here S square coefficient is 1. So B minus 4A equal to 1. Here S coefficient 5A minus 4B plus C. Here you can see the coefficient of S is your minus 6. So minus 6. 5b plus d is the coefficient of s to the power 0 means constant. Value is 7. Now if I will solve these four equations, I can found already a we found 0, b will be 1. Here if I will put 0 then b will be 1. Then if I will put a and b value these two equations, we can found c equal to minus 2, d equal to 2, and here we substituted these values a, b, c, d. In this equation we found that a square minus 6s plus 7 by a square minus 4s plus 5 whole square. Here a is 0, b 1, that means 1 by this one, and your c is your minus 2, so minus 2s, d minus 2s, d is your 2, so it will be plus 2 by a square minus 4s plus 5 whole square. Now I am going to rewrite this denominator as this one can be rewritten as s minus 2 whole square plus 1 square. Here you can see a square minus 4s plus 5. S minus 2 whole square will be a square minus 2s plus 4, and this one will be plus 5. Okay, so here this will be s minus 2 square plus 1 or 1 square to the power 2 to the power 2. So this will be minus 2s plus 2. Okay. Now we are going to consider inverse Laplace transform both the side, because we need to find out inverse Laplace transform of this one. So here I applied inverse Laplace transform on this one, inverse Laplace transform on this one, inverse Laplace transform on this one. Say here two terms are there, minus 2s by this one plus 2 by this one. So inverse Laplace transform of this one, inverse Laplace transform of this one, right? So inverse Laplace transform of this one will be e to the power 2t sin t. How it is already we know. We know that if we have this function, that is your 1 by a square plus 1 will be sin t, or a by a square plus a square is your sin at. So here a is your how much 1. So if we have only 1 by a square plus 1 square, it will be sin t. The answer will be sin t, but here s minus 2 is there. Instead of s minus 2 is there, means here we have to use the fast shifting theorem. According to the fast shifting theorem, we already know and discussed several times in our previous classes that the value will be how much? This one. Here you can see by using fast shifting theorem, it will be e to the power 80 f of t. So instead of sin t, we have to write e to the power 80. So what will be the a? A will be 2. So e to the power 2t. Okay. So e to the power 2t sin t will be the answer by using fast shifting theorem. Okay. You can also check your note that when I discussed inverse Laplace transform of 16 formulas or 16 functions, here you can see inverse Laplace transform of omega by s minus a whole square plus omega square equal to e to the power 80 sin omega t. These all the results 10, 11, 12, 13, 14 results based on the fast shifting theorem. So here instead of a we have 2 in our question, and instead of omega 1 is there. So the answer will be e to the 2t into sine t. Now inverse Laplace transform of minus 2s by s minus 2 whole square plus 1 square whole square. Okay, so what will be its value? So here you can see that here it is in the form of minus 2s by s minus 2 whole square plus 1 square whole square. I just modified this one as 2 into 1. Instead of s, I have been written s minus 2 by s minus 2 square plus 1 square whole square. And if I will be modified s as s minus 2, then here minus 2 is there, right? So here instead of minus 2s, if we just modified s minus 2, that means this is 2s plus 4. So I have to consider minus 4 itself. Okay, if minus 4 I will consider, then here is plus 2 is there. So plus 2 and this is minus 4. So finally I will get minus 2. So here I omitted just one or two lines, but I here explained carefully. You have to watch. Just go back the video and carefully you just watch that how it is 2 into 1 into s minus 2, and this is plus 2, it will be minus 2, because if it will be s minus 2 I will be modify, then the term will be minus 2s plus 4 minus plus 4, but we need only minus 2s, so I have to consider minus 4, right? If minus 4 I will be consider, here it is plus 2, so minus 4 plus 2 will be minus 2, right? Now why and why we have been modified this one? Here carefully you have to watch. Here we found that 2 into 1 into s minus 2 by s minus 2 whole square plus 1 square whole square. Carefully you have to watch. In those 16 formulas or 16 basic functions and corresponding Laplace inverse Laplace transform, you can check your note. You can find that here inverse Laplace transform of 2as by a square plus a square whole square is your t sine a t. Okay, so if I will compare this one 2as by a square plus a square whole square, here a is your 1. Okay, here a is your 1. 2 into a into s, instead of s it is s minus 2, but here a square is your 1. So instead of a we have 1. So if 2as by a square plus a square whole square, so we can write t sine a t. But in our case, instead of s it is s minus 2. S minus 2 means we have to use the fast shifting theorem, right? If we are going to use the fast shifting theorem, instead of this answer we have to write e to the power bt or s minus something. If here it will be s minus b square, then the answer will be e to the power bt t sine at by using fast shifting theorem. Exactly same format we can found here. 2 into a, here a square, s minus 2 or s minus b, here s minus b square. The answer will be e to the power 2t or e to the power bt into t into sine at. Here a is 1, so answer will be t sine t into e to the 2t. The inverse Laplace transform of this one is your this one. Now we are going to go for inverse Laplace transform of 2 by 2 minus s minus 2 whole square plus 1 square whole square. Okay, here you can see that the inverse Laplace transform of this one, or if I take the 2 outside, the inverse Laplace transform of 1 by s minus 2 whole square plus 1 square whole square. The inverse Laplace transform of this one, straightly I have written over here. The value is this one, 1 by 2 into 2 to the power 1 or 2 into 1 to the power 3 sine t minus t sine t cos t into e to the 2t. How? Already we solved this numerical that is inverse Laplace transform of 1 by a square plus a square whole square is this one. Already we have been solved. You can check your note, convolution, when we discuss the convolution. Okay, this one. Numericals on the base of inverse Laplace transform by convolution. One numerical we found, this one, inverse Laplace transform of 1 by a square plus a square whole square. Answer is your 1 by a square aq sin at minus at cos at. So if a will be 1, then this value will be 1 by 2 into 1 to the power q sin 1 t means sin t minus t cos t, whatever I written directly. Okay, this one. Okay, but why we have been written e to the 2t here? If 1 by a square plus a square whole square, then the answer will be this much. Okay, but if it is s minus 2 square is there, that means we have to use the fast shifting theorem. E to the 2t will be multiplied. Okay, clearly I have been written over here. This value is this one. By fast shifting theorem, inverse Laplace transform s minus b, that means here b is your 2. It will be e to the power bt into f of t. The so called f of t will be this much. If a is your 1, then this much into e to the 2t. Okay, okay. Now finally we found the answer will be here e to the power 2t sin t, e to the power 2t sin t minus t sin t e to the power 2t. This one here I multiplied this one. Here you can 2 into 1 by 2 into sin t e to the 2t. That means sin t e to the 2t minus sin t e to the 2t. Then this is minus and plus t cos t e to the power 2t. So here minus sin t e to the t plus sin t e to the t got cancel, e to the 2t, e to the 2t. These two terms got cancel and these two terms are there. If we are going to take common e to the 2t t outside, then this will be cos t minus sin t will be the answer of this question. Okay, now we are going to go for another question, belongs to type 4. That is your find inverse Laplace transform of 2sq minus a square minus 1 by s plus 2 whole square into a square plus 1 whole square. Okay, here you can see in the denominator one linear repeated is there, one quadratic repeated. Here s plus 1 square is the linear repeated, a square plus 1 whole square is a quadratic repeated is there. How we are going to solve it? We have to apply both type 2 and type 4. Type 2 principle, type 2 means linear factor repeated. This one we have to apply. Type 4 means quadratic and repeated also we are going to apply the rule. The two rules we have to apply at the time of partial fraction. Now consider the partial fraction of this one, that 2sq minus a square minus 1 by s plus 1 whole square into a square plus 1 whole square will be, first we are going to consider type 2 means linear repeated, a by s plus 1 plus b by s plus 1 square plus cs plus d. Then we have to consider this one means repeated quadratic, cs plus d by a square plus 1 plus es plus f by a square plus 1 whole square. Let this is your equation number 1. Now simply I just added the 4 terms. We can found at the denominator this will be s plus 1 whole square into a square plus 1 whole square, and if I will add it carefully, you have to watch here a by s plus 1. So when at the time of adding it will be here you can see s plus 1 square is there at the denominator, so s plus 1 into a square plus 1 whole square plus b by a square plus 1 whole square, that means b by a square plus 1 whole square it will be multiplied. Cs plus d by a square plus 1, that at the time of adding cs plus d, this one s plus 1 whole square will be multiplied into a square plus 1 will be multiplied. Simple addition plus es plus f into s plus 1 whole square. I just multiplied all. That means first s plus 1 into a square plus 1 whole square I multiplied. I have been written here. Carefully you have to, if you want you can do it your in your rough. So I multiplied these two terms. We found we can found that s to the power 5 2 s to the power 3 plus s to the power 4 plus 2 s to the power 2 plus 1 plus b into this one will be s to the power 4 plus 2 s to the power 2 plus 1. If I will multiply this one s plus 1 whole square, a square plus 1, we can found that s to the power 4 s to the power 2 plus 2 into s to the power 3 plus 2s plus a square plus 1. Then this one is your a square plus 2s plus 1. That means s plus 1 whole square is this one. Again I multiplied a with this, b with this, cs with this, ds, d with this, and just simple multiplications I found these terms, that a s to the power 5, a this one, your here you can see, here a s to the power 5, here a s to the power 4, okay. Then 2a s to the power 3, okay. 2a s to the power 2, a s, a into 1a, b s to the power 4, 2b s to the power 2, b into 1 b. Then cs into s to the power 4, that means cs to the power 5, c cs into s square, that means cs cube, cs into 2s cube, that means 2cs to the power 4, cs 2s, 2cs square, cs square, cs cube, cs into 1 cs. Again d multiplied with these terms, we found ds to the power 4, ds square, 2ds cube, 2ds, ds square plus d. Then es plus f multiplied separately. When es multiplied, we found es cube plus 2s e s square plus es plus f multiplied with these terms, f s square plus 2sf plus f. Okay. Now we are going to write collectively for each power of s. So here s5, another s5 is here. So if I will take common s5, then it will be s a plus c. You just carefully watch. This is tick mark. Tick mark belongs to s to the power 5. Then s to the power 4 is your cross marks. Here one s to the power 4. Here one, another one. Here another one. Okay. So here a s to the power 4 coefficients are a. Then this is your b. This is your 2c. This is your d. Okay. Then the coefficients of s to the power 3. Here dot marks. 2a c, 2a. Here one c is there, here another c is there, so at a time I have been written 2c. Then 2d, 2d, then e is your e. Okay. sq coefficients, s square coefficients are marked by underline. So here 2a, 2b, 2c, 2c, 2d, and 2e and 2f. So s square coefficients are 2a, 2b, 2c, 2d, 2e, 2e, and only f, only f. Okay. Then s coefficients are marked by this arrow. Here you can see as means a, here c, ac. We found another, here we can have 2d, 2d, e, 2f. Okay, 2f. Then constants are your a, b, then d, f, a, b, d, f. Now we have to equate the coefficients of a square, s to the 5, s to the 4, s to the 3, s square, s to the 1, s0. S0 means constant, this one. LHS and RHS, what we can get? LHS means this one. Here I have to write. That implies 2s cube minus a square minus 1 will be equal to this one. Numerator. This is numerator. Okay, numerator divided by this was your is your s plus 1 whole square, a square plus 1 whole square. So numerator of this one and numerator of this one, coefficients of s has to be equal because the denominator are same. If I will equate, then we can found a plus c will be 0 because you can see in your denominator there is no s to the power 5 terms are available. So s to the 5 coefficient is your a plus c, so a plus b will be equal to 0. Here I written a plus c will be equal to 0. Then s to the power 4, s to the power 4 coefficient is your a plus b plus c plus d, but in your left hand side there is no s to the power 4 term, so obviously this one will be equal to 0. A plus b plus 2c plus d will be equal to 0, right? Will be equal to 0. Then s square, sorry, s cube s to the power 3, s to the power 3 coefficient is this one, and here left hand side is your 2. So this much equal to 2. Okay, this much equal to 2. Then mm, then yes, then s cube on s square coefficient is this one, will be equal to -1. That means 2a, 2b, 2c, 2d, 2e equal to -1. Here I written -1. Now constants, sorry, s coefficient, f s coefficient, that means a plus c plus this much terms coefficients right hand side will be equal to 0, because there is no s term in your left hand side. So this one a c, a plus c plus 2d plus e plus 2f will be equal to 0. Then constant terms will be equal to -1, because here a plus b plus d plus f will be equal to -1. Left hand side constant is -1, right? Okay. Now we are going to solve. Carefully you have to watch. Here a plus c we found equal to 0. That means a equal to -c. Okay, a equal to -c. Let this is your equation number I. Now if I will put a equal to -c over here, then this will be minus c to c. So it will be plus c plus d to c minus c. D will be equal to 0. Let this is your equation number 2i. So here I put a equal to -c. This will be minus 2c. Plus 2c is there, 2d plus e equal to 0. That means this 2c and minus 2c got cancelled. 2d plus e will be equal to 2. Let this is your equation number 3i. Here you can see, if I put instead of a equal to -c, so this will be minus 2c, 2b, 2c, 2d, 2e plus f equal to -1. Here 2c minus plus 2c got cancelled, and remaining 2b plus 2d plus 2e plus f equal to -1. Let this is your equation number 5, right? Let this is your equation number 5. Now here you can see equation number v. Here you can see, if I will put a equal to -c got cancelled, it will be 2d e plus 2f equal to 0. Or if I will put d equal to 1 here, d equal to, or you can see 2d plus e, we can put 2 directly. 2d plus e equal to 2 plus 2f equal to 0. Here I written put 3i. Put 3i means we found this one, and f will be equal to -1. Let this is your equation number iv. Okay. Now here you can carefully, you have to watch that d we found 1. We found d equal to 1. If I will put okay, first we have to solve this one. So here let this is your equation number v. Now if I will be consider these two terms, 2 into b plus d plus 2e, here f we found -1. This is -1. If I will take this side, it will be 0. Then b plus d will be equal to 0. Here you can see, if c we can found 0, that means b plus d c will be 0, means b plus d will be 0. So if I put b plus d equal to 0, then 2e equal to 0, e equal to 0. Here I clearly written put v double I and iv. If we are going to put this one, we can found. And if we are considering this equation, instead of a, see, a plus b plus d, f is your -1 equal to -1. Then a plus b plus d equal to 0. Then minus c, if you put instead of a, minus c, b plus d equal to 0. So b plus d equal to 0. Okay. So now equation number 2i. Equation number 2i is your b plus c plus d equal to 0. So you just consider this one and add these two equations, and we found b plus d equal to 0. So here b plus d equal to 0, that means b double I. So here we found b plus d equal to 0, and this value here I substituted. Okay, b plus d equal to 0, and e we found. Okay, you just serially you have to watch. This is your I, this is your 2I equation, third I, then IV equation, then after IV equation you have to consider, then V equation you have to consider, then VI. Where is your VI? See, VI is your equation, this one, and this is your V double I, then V double I, then V triple I. V triple I is your this equation. By substituting V double I and IV, we can get V triple I. Then IX. Then IX is your this one. IX equation is your this one. That means as we found E equal to 0, V triple I, then we have to substitute this E will be equal to 0 over here. So D will be 1. Let this is your equation number IX. Now we are going to go for IX. We have to substitute over here. Here D we found 1. So B plus D equal to 0. B plus 1 will be equal to 0. D we found 1, so B equal to minus 1. So here we found all the constants. A equal to 0, C equal to 0, D equal to 1, and then A, B here, B equal to minus 1, B, C already we found 0, and D equal to 1, E 0, F minus 1. So these calculations is somewhat tedious, but you have to practice. Okay, you have to practice this calculation, how to solve and to find out the how many variables. A, B, C, D, E, F, 6 variables you have to find out, and just substitute this A, B, C, D, E, F values in equation number 1. We get equation number 1 is this one. A and C are 0, 0. So here A value is 0. This term will be cancelled out, and B is your minus 1. That's minus 1 by S plus 1 whole square. Term is there. This term is there. Then C is your 0, because A is 0 means C will be 0. C will be 0, but D will be how much? D will be 1. So 1 by A square plus 1. Another term, second term will be 1 by A square plus 1. Then ES plus F. ES plus F. So E is 0. F is your minus 1. So minus 1 by A square plus 1 whole square we found. So finally we found these three terms by substituting these values in equation number 1. Now we are going to take the inverse Laplace transform both the side. So by considering the inverse Laplace transform of this one, so it will be minus already is there, minus taken outside, inverse Laplace transform this one, and this one, minus inverse Laplace this one, inverse Laplace transform this one, inverse Laplace transform this one. So here 1 by, we can add 1 by s minus of minus s whole square, and this value is t by 1 factorial. We know that 1 by s square inverse Laplace transform is nothing but t by 1 factorial, that we know. But as it is s minus of minus 1 is there, by fast shifting theorem, this happens by fast shifting theorem. By fast shifting theorem, this value will be e to the minus t will be multiplied with this one, right? Then here you can see this is a straightforward 1 by a square plus 1, that means a by a square plus a square is there, that means answer will be sin t. And inverse Laplace transform 1 by a square plus 1 whole square will be equal to this much. Already we have been discussed in our previous question that if we have 1 by a square plus a square whole square, this will 1 by 2aq into sin 80 minus 80 into cos 80. And here you can found the question is here we have 1 by a square plus, instead of a 1 is there, so answer will be 1 by 2. A means 1, so 1 by 2 sin t minus t cos t. So finally what we found, inverse Laplace transform of this one will be equal to how much? Here this term will be minus c, minus c. It is here sin t, this is your minus half sin t. So if I will subtract, we can found half plus half sin t, and this is your minus t sin e to the power minus t, and this is your minus plus half t cos t is your answer. Okay, so here we have been completed in our last video. We have been completed the type 1 and type 2 type and corresponding numericals, and In this video, we have been completed type 3 and type 4 questions. Questions corresponding partial fractions. And in our next class, we are going to go for application of Laplace transform to differential equations. So thank you so much for watching this video. Thank you.